So the purpose of this is to spend a few minutes demonstrating the functionality of Worldwide Telescope, and then also throughout this, definitely ask questions if you want to learn more. We can both hear each other, so just speak like we're having a conversation.
Sounds good.
And so Worldwide Telescope is a bunch of stuff behind the scenes, which is servers and tools to convert data, and then the data themselves. And then we're going to be talking about a couple, the two most powerful front ends. And the most powerful and most mature is this desktop client that currently runs under Windows. But the Windows application has these different modes. One mode is looking at when you first start it up. I think it starts with Solar System, and just to show you what that does, this is a 3D representation of our solar system. In a solar system view, one of the cool things you can do is you can actually look at it face on.
Oh, nice.
Then you can this is actually you can see up here, and this may not be you may have to make your screen full size to see this, but basically there's a time controller here where I can advance things day by day, and when I apply it, it should actually the easiest thing is actually to speed up time. So if you see the planet orbits moving slowly.
Yeah.
Okay, I can make them move more rapidly. So this is if I stop at any time. So if you wanted to see this is a way to teach things like I've taught some classes at Northwestern where I talk about why space missions to Mars are sent every couple years during opposition when the two planets are close together. And you can easily kind of advance time to that location, that time, see that they're close together, see that in a year past they're very far apart, and then a year, and then in 2 years they're back to being close together. The other cool thing in this mode is that we actually have the asteroid orbits as well. So so you see here, actually these are not just the planets moving, but the asteroids themselves. So you see and they're broken up into different zones. Right now I'm zooming in on the sun, so you'll see the yellow here are the Trojan asteroids, and they're moving pretty fast. So let me kind of slow them down a little bit. And then the kind of magenta going from light to dark magenta, or the main asteroid belt. Now, of course, the data. The different planetary bodies are represented with the data we have available to us. So the Earth, because of all the remote sensing on the Earth, we have a lot of data on the Earth, and so things like I can go to New Zealand, and like zoom in on mountains. And by the way, all the data here are being pulled in real time. If you're doing tours, there's a way to cache the data before you run it, but since we're doing it live, some of the representations will be built up as data gets pulled across the network to be viewed. So now I'm zooming to New Zealand, here a mountain range, and I'm not very familiar. I've never been to New Zealand, so I'm not sure what mountain range it is, but as you see it, I can get closer to it, and the levels of detail kind of get added. And so this is the same way that Google Maps and Bing Maps and all the different mapping services work. And so this is the Earth. So this is the solar system mode. The other mode is the sky mode. And in the sky mode, and this is a thing that is probably of great interest, for the journals and things like that, where I can click on any object. So for instance, here, everything along the bottom is called a context menu. As I mouse over different objects, you're seeing a circle in the main view, right?
Yes.
So now in the objects in the lower, these are objects that are in the field of view. If there's a little kind of icon with a picture on the upper right, that means there's a separate image that's a pointed observation that's available of that thing. So for instance, here's one called. The titles of these come from various locations. Sometimes there are various sources. When I click on it, it'll take me to that location, And so if I zoom in, you see this zoomed in image of this is probably Hubble on top of the background at much higher resolution. You see that the zoom in, okay, and then when I crossfade between them, I crossfade out the overlaid high resolution image on top of the lower resolution background, and you see there's a pretty good registration of that. So as I pull out, I see more and more objects populating this context menu because my field of view is getting wider, and the database that is the Worldwide Telescope has access to will have more objects in it. So if I stop here, you'll see that now they're populated with, looks like there are a couple of planets in my view. There's a Cloud cluster. There's a few galaxies and NGC cataloged objects. And then there's also a thing of guided tours. And these are tours that either are served to the user via the interface, or I can create my own and save them locally as files. So if I were teaching a class on, like I did at Northwestern on the solar system, and I had a class on Mars, I could go explore, open, tour, and now I'm going to be opening a tour that I created. So I'm going to go over to Documents, Worldwide Telescope, Tours, and so for instance, here's a tour of actually this is a cool tour. This tour shows came from a class at Columbia College in Chicago, where they had students peruse through high-rise imagery from Mars, which is on Mars Reconnaissance Orbiter. And the students found this one hole in the image, which it's a cave collapse probably, that we're zooming into, and the high-rise team hadn't even seen it. So the professor, Jim Schweitzer at Columbia, got in touch with them, and they had some correspondence between the students, the professor, and then the people in high-rise to confirm that this was a new discovery. And so students put this tour together, and all it was simply highlighting this one object. And the students could have added narration to it to say what they're seeing and things like that. But this is a good example of data sharing, where they found something that they thought was cool, and it can be shared with somebody where somebody else can actually go in and look at it not like as a video or a screen share, but as an interactive. This tour is an interactive, object that I can play around with.
The functionality is great, and it reminds me a lot of Starry Night Pro, which of course I get advertisements for in my email all the time. Hey, right, use this for a tool. And obviously, Worldwide Telescope is far more than that. So I'm curious to know a couple of things in that regard. As far as this and Starry Night Pro, how do you transcend it? And then let's say we wanted to use that cool registration tool that you used in crossfading for actual, say, student research type projects, similar to the one that Jim did with his students here on Mars. Can they do that in sky mode, where they're looking beyond out into the universe and things like that, at a galaxy or a star cluster or something like that?
Yeah, exactly. So first the question was, how is it compared to Starry Night Pro or some of those other tools? In general, I think the tools like Starry Night, and actually there's a similar aspect, which is the planetarium tools that run professional planetariums, have a similar 3D solar system view like this. The one difference, a couple differences. One is it's number one, it's free. So all those planetarium tools, and although Starry Night does have some educational and different organizations can get discounts or site licenses, things like that, Worldwide Telescope is completely free. So the nice thing about that is that if you want to have your students do a project, there's no, you just point them to a website. Then as long as they have now the Windows installer is the one thing that right now the full functionality requires Windows. You can do quite a bit. And this is probably one of the things we could do with the web client as well. But some of the more complicated things need the graphics performance of the desktop client. But we're close. The team is close to adding WebGL, which is a way to get to the graphics hardware to enable a very beautiful rendering. For instance, if I go back to the solar system mode and look at Mars as a planet, let me turn off the overlaid. I can put grids on it, which is nice to know where you're at. That's actually pretty important when you're trying to find locations. I get this all the time when I look up a paper and I try to find lat long coordinates. But if I zoom into this and then put this up at an angle, you see there's a nice atmosphere, and again there's coordinates to help me give me a context. All of these sort of things are really kind of best in class visualization in terms of lighting, atmospheric models, all this. So it's kind of as good as Starry Night in most of those cases. And then the sky mode is actually quite powerful, and the ability to your students, for instance, could take an amateur telescope, and there's a way to connect through an ASCOM interface, a telescope through a wide telescope. I don't have one connected to this my home computer, but if I had one, I could connect to the telescope, take a picture. It would plop it up in the sky in the right location. So that all that crossfading that you could do here could be done in a tour to either the students could do a research project, a lab, and then they would create a tour to represent their understanding of that topic. So if I click on this image, it's a TIFF image that has these things called astrophysical metadata, visual metadata standard embedded in the header of the TIFF image. And so this image is actually a TIFF that's overlaid on top of the night sky, on top of the DSS background. You see I'm crossfading between them. And so this TIFF that I'm looking at, and the registration isn't actually, it's pretty good between the two, but that it's actually overlaying that on top of the DSS background, and places like various Hubble PR and data sources, Spitzer, different observatories either make their raw images or their press release images, embed them with these tags. So if you had one on your desktop, you could actually very easily view this. And this is actually one of the things that it's exactly the same performance and interaction mode in the web client as the desktop client.
Great. So, for example, if I really like this galaxy and I want my students to look at this object in the infrared and then the ultraviolet, there's a tab that I can sort of click and say, show me the Spitzer image, or show me the IUE spectrum, I guess, or the image from some other mission or something like that, like Galax or something like that.
Exactly.
These sorts of things are all available.
Yeah, so there are two ways to it. One is the background. You can say, look, like right now I can I have this pointed image, and I can, instead of right now it's on top of the DSS background, I'll turn that back on. I'm going to turn the background now to be a WISE infrared image. Now some of these things are going to be very different spatial scales. So you see the and I'm not sure what the origin of this image is, but it's obviously much higher resolution than the WISE background. Let me try a 2-mass. Okay, this is a little bit. Okay, so this is a good example. So this is 2-mass in the background and this pointed visual image in the foreground. And so I can make that change, or I can go over here to explore, and then go up a level, and then I can look through different surveys. So I can say, what does Spitzer see? How do things look different by looking at catalogs of images from different missions?
Now, I guess it would be too much to ask the program to provide me with some photometry too, huh?
Yeah, now that's one of the things. I mean, right now the program doesn't do that. There's a conversion stage that converts the FITS files and the quantitative information into a color image, and that color mapping is done, and we lose the data values behind it. There are ways to extract coordinate information based upon what you're looking at within Worldwide Telescope, and then there's an interface called SAMP, which is the one versus TopCat. I don't know if you're familiar with TopCat. It has an interface to for it to like pull in data, and then you're driving TopCat to pull in data from different sources based upon a position on the sky. So in that, one of those sources could be a FITS file or some photometric catalog. So it's kind of connected to other tools that bring in the quantitative information, and then use Worldwide Telescope as the visual interface to explore, and then it pulls in the numbers from some other data set.
Great, thanks.
So
well, I think this is just a terrific tool to be able to zip around the sky, showing the pictures, and then depending on how you structure your class or the levels that you structure your class with, you start with a lower level and then they zoom and they play with images and learn from that. And then from there go on, if they want, to places like TopCat or to NED or to other places and pull up the more sophisticated work if they're actually doing some sort of in-class research, because that's
exactly.
the sort of,
yeah. And there's one last thing just on that point of research, where if I go to explore, I can say show finder, and there's a finder scope. And then if I say research, this allows me to exactly do what you just said. If I go to like M31, if I click on this, it takes me there, and then I show the finder, and then I say research information, look up on ADS, for instance. It's going to take the name M31, send it as a query to ADS, and now I'm getting all the papers that are published as if I had in a separate browser just typed in M31, but I'm able to do this all within my visual interface to see the context where I'm at. And so this is a great way for students that, where you have this visual portal into data that doesn't just end with the with the images that are in Worldwide Telescope. It actually has ways to query external data sets and sources like ADS and NED and SIMBAD that are curated totally outside of Worldwide Telescope, and without having to learn a whole nother. We're all very familiar with ADS, but as a student, this is kind of a good way to get connect research. Real research to be able to get the full proposal. And actually this is probably going to fail because I'm not on my VPN. Okay. So there actually is a way to get that, the abstract from within Worldwide Telescope. And then the other thing that we were able to do was actually create tours, have the students create tours. So, it's like in 2 minutes, I'll make a really short tour just to kind of give you a sense of how easy it is to do. So if I say create new tour, I just say I'll say Mars. I say add new slide. This is a starting position, and let's say I'm gonna just come out to this view and say set in camera position, and then if I push play, I've now created a one slide tour that just does this little thing. You can imagine then just stringing together one slide to another to do the kind of storytelling, either you as a presenter, as a lecturer, or if you're having your students represent that they know some understanding about an object, or they investigated Mars or volcanoes or whatever the topic you're having them do. It's very easy for them to create content. So that's another thing that's compared to I think most of the other software systems that do this kind of 3D stuff. A lot of work has been done to make this very similar to PowerPoint and doable without a lot of technical background from kind of production experience. So that was one of the things that worked out pretty well in a classroom experience where they could work on a tour again that represented their understanding about a topic or a phenomenon.